To solve algebraic equations, we will explore several different strategies. First, word to equation strategy. Example, a number times 3 plus 4 is equal to 25. When we break down the statement, it is really saying that a number multiplied by 3 is the same as 25 minus 4, which equals 21. This means the number, when multiplied by 3, must give 21. Now think about what number multiplied by 3 produces 21. That number is 7. So the unknown number is 7. Now let's translate the sentence. Let the number be n. Times 3, 3n. Plus 4 is equal to 25. Final equation, 3n plus 4 equals sign 25. Second, use inverse operations and keep the equation balanced. This is the core strategy. Whatever is happening to the variable, you undo it with the opposite operation. Addition, subtraction, multiplication, division. What you do to one side, do to the other, always. This prevents you from changing the value of the equation. Example, solve 3x plus 5 equals sign 20. Subtract 5 from both sides, and you are left with 3x equals sign 15. Divide by 3 both sides, and you get x equals sign 5. Third, use a model, tiles/diagrams, for conceptual understanding. Model your equation using a balance scale. You may also use algebra tiles or any type of visual representation you prefer. In this example, we will use a balance model. We want to solve the equation 2x plus 3 equals sign 7. Imagine this equation as a balance scale. On the left side of the scales, we place 2 x's because of the 2x. And 3 unit blocks because of the plus 3. On the right side of the scale, we place 7 unit blocks because the equation equals 7. Since a balance scale must stay even, whatever we do to one side must also be done to the other. So, to start solving, we remove 3 unit blocks from both sides. This keeps the scale balanced. After removing the 3 units, the left side now has only the 2 x's, and the right side has 4 unit blocks left. Now think about the situation. If 2 x's together weigh the same as 4 units, then each single x must weigh half of 4, which is 2. So the value of the unknown number, x, is 2. Fourth, distribute first before solving. If parentheses are present, use the distributive property to expand. Example, we want to solve the equation 2, 3x minus 4 equals sign 16. First, imagine this equation as a balance scale. On the left side, we have 2 groups of the expression, 3x minus 4. This means we have the same package twice. Each package contains 3 x's and 4 units being taken away. On the right side of the balance scale, we have 16 units. You could solve this using the same idea as before. If you think of removing or breaking apart each group equally, the scale must stay balanced. But there is also another very common method that students often find easier. Using distribution. A quicker way to solve this equation is by using the distributive property. Because the number 2 is multiplying the entire group, 3x minus 4, we can distribute the 2 to both parts inside the parentheses. So we multiply. 2 times 3x, which becomes 6x. 2 times minus 4, which becomes minus 8. After distributing, our equation becomes 6x minus 8 equals sign 16. Now we want to get the x term by itself. Add 8 to both sides of the equation to undo the minus 8. This gives 6x equals sign 24. Now divide both sides by 6 to undo the multiplication. That gives x equals 24 divided 6, which is 4. So the solution to the equation is x equals sign 4. 5. The magic river rule. This is Mr. Buchrich's rule. Imagine that the equal sign in an equation is like a magical river. Everything on the left side of the equation is on one side of the river, and everything on the right side is on the other side. Now here is the important part. Whenever a number or operation crosses this magical river, it changes into its opposite, also called its inverse operation. For example, if something is added on one side, it becomes subtracted when you move it across the river. If something is subtracted, it becomes added on the other side. If a number is multiplied, it becomes divided when it crosses. And if something is divided, it becomes multiplied on the other side. This idea helps you understand why we do opposite operations when solving equations. It reminds you that when we move a number from one side of the equation to the other, we must change the operation to keep the equation balanced and fair, just like a real balanced scale. Example, solve the equation. X plus 5 equals 12. To solve this equation, we want to get x by itself. Right now, x has a plus 5 attached to it. Imagine the equal sign as a magic river. If we want to move the plus 5 to the other side of the equation, it must cross the river. When it crosses the river, it changes into its inverse operation. Since it is plus 5 on the left side, it becomes minus 5 on the right side. So the equation now becomes x equals sign 12 minus 5. Now we simply subtract. 12 minus 5 equals sign 7. So the solution is x equals sign 7.